Hi guys, we're going to continue 5-5 solving polynomial equations. Yesterday you should have worked on factoring using sum and difference of cubes. There are a couple of corrections I want you to make, and the first one is on example 1. If you look here, look at where I wrote in red, a should have been 2x, and so that kind of changed your answer. So just make sure, and then this middle part was 4x squared minus 6y plus 9y squared. All right, moving forward from there, we're going to continue factoring, but today we're going to do it by grouping. And this is something that you guys have learned before, but I just want to kind of go over some of the basics of it. So whenever we're factoring by grouping, we want to organize some groups here. I'm going to organize some groups. And within that group, I'm going to try to find the GCF. And I'm looking at this first group, and I would say that there's a GCF of x squared. And in this second group, there's a GCF of 2. And I'm going to see how that works out once I pull out that GCF. So if you notice here, once I remove the GCF of x squared, what I'm left with inside the parentheses, when I'm doing grouping, those two sets of parentheses should match exactly. Since they don't match exactly in this case, we'll have to rearrange this equation a bit. And how I'm going to rearrange it is I'm going to look for the terms that have the same exponent, and I'm going to start by just trying to switch those and see what works out. All right, I have switched those two terms, and now I'm going to try to form my groups again. I'm going to form two groups, and within those two groups, again, I'm going to find my GCF and factor it out. In my first group, I again have a GCF of x squared. And in my second group, I now have a GCF of -4. I'm going to work that out and see if my two parentheses end up being the same this time. If I notice one thing, when I factored out an x squared in the green group and a -4 in the red group, that my two sets of parentheses turned out to be exactly the same. So that's really good for me. That's what I needed. If they turn out to be exactly the same, I know that I was successful in factoring, and that becomes one of my factors. X squared plus 7x plus 10 is one of my factors. And then my second factor comes from what's left outside, x squared minus 4. I'd want to make sure to recall something. Whenever I'm working these problems, I'd like to think, hey, am I done factoring? Am I truly done factoring? Can I factor this any more than it already is? So I'm going to look at this blue group, and I notice it's a quadratic trinomial. So off to the side, what I'm going to do is see if I can factor this anymore. A is 1, B is 7, C is 10, and AC, again, is 10. Are there two numbers that multiply to give me 10 but add up to 7? 5 and 2. So this would be x plus 5 and x plus 2. And then in that purple group, I have a difference of perfect squares, which would give me x plus 2 and x minus 2. Good, so we have now finished factoring this problem. What we're going to do next is actually try to solve it. So when I solve, notice the difference is that this is set equal to 0. It's the same equation, but this time it's actually set equal to 0. What I'm going to do is just copy down the factors that I have, and notice it says solve x plus 5, x plus 2, another x plus 2, and a x minus 2 equals 0. When I solve a polynomial, all I have to do is set each of these factors individually, set them equal to 0, and solve them. So x plus 5 equals 0. Notice I set them equal to 0, and then that x plus 2, I'm not going to write it twice. I know it has that multiplicity of 2 because it's written twice, but I don't have to actually write it twice when solving. And x equals positive 2. I would just solve each of these for x, and then that's how I would get my answers for my zeros. Okay, good. we're going to try another one together. Let's look at this problem and see if we can do it without rearranging. I'm going to set up two groups. And when I'm working these two groups, I'm trying to think, okay, is that set of parentheses going to be exactly the same inside? So in this first group, it looks like, again, I have an x squared that I can factor out. And what would I be left with? I would be left with 2x squared minus 3x plus 12. And looking at my second group, this looks a little bit wonky. To me, these aren't even in the correct order. I should switch these two around. But even besides that, my GCF would be -1. And if no matter which factor I'm looking at in here, if I pull out a -1, I will never get a 2x squared. So I know automatically that I need to go ahead and rearrange this. So that's what I'm going to do. When I rearrange this, I'm going to switch out my x squareds because they are my repeating exponents here and here. And I'm just going to put these kind of in standard form, making sure that this -18x would come after. So, all right, so I have rearranged. Notice the main reason why I put that 12x squared in front of the 18x is because I wanted to make sure that my parentheses turn out to be exactly the same inside. So if I'm looking at this first set of parentheses, it looks like, again, x squared would be my GCF. And looking at this second set of parentheses, I'm going to say that 6 is my GCF. So I'm going to work that out. What's really nice about this one is my two sets of parentheses turn out to be exactly the same. So I know that that's one of my factors. One of my factors is 2x squared minus 3x minus 5. And my other factor comes from the outside of the parentheses, so x squared plus 6. X squared plus 6. From there, again, you want to always check, can I factor this any more than it already is factored? So I'm going to just try and look at it and see, okay, this is a quadratic trinomial. Can I factor that any more? Let's determine by looking at A, B, and C. I'm going to write it off to the side here. All right, so for this first set here in parentheses, I wrote down A, B, and C and AC. So two numbers that add up to -3 but multiply to -10 are -5 and -2. So I'm going to have to do grouping within grouping, if that makes sense. I have to split the middle term. -5x minus, sorry, plus, that's plus 2x minus 5. And then 2x squared. So what's nice about this part, though, is that even though I'm about to do grouping, it's much quicker and easier because it's just quadratic. So let's see. In my first group, I have a x in common, and I'm left with 2x minus 5. And then in my second group, I have just a 1 in common, but you have to have something, and then again 2x minus 5. So my factors are going to be 2x minus 5. Then I have this x plus 1. And then don't forget this one. I have x squared plus 6. So that is me factoring this. On the next slide, we're going to solve. So I've already set these first two factors equal to 0 and solved. I just wanted to show you this last one to remind you of something. If I am working this one, I have something squared is set equal to a negative number. So if I take the square root, I'll have x equals the positive or negative square root of a negative number. But of course, we know that the square root of a negative number is imaginary. So this is going to be square root of -1 times the square root of 6, which is I square root of 6. So I just wanted to give you that little reminder. So this is positive or negative I square root of 6, for this answer here. Okay, there's one more. I want you to pause the video and try this one on your own. I'm just going to give you a heads up that yes, you will need to rearrange it. And then when you get your factors in the end, you're going to have to use quadratic formula to get that final answer. But go ahead and pause the video and try it here. All right, so this is the one that people thought was a little bit ugly. So if you look here, I did rearrange it. First of all, I switched the negative 5x squared and the negative 4x squared. I found the GCF to be x squared in the green group and negative 4 in the red group. And notice my parentheses were the same, so I got x squared minus 5x minus 5. And then on the outside, I had x squared minus 4. X squared minus 4 factored into x plus 2x minus 2, so I got two nice answers. But this first set of parentheses, it can't factor. So if I can't factor, what I have to do is find another way to solve, and it's quadratic. So I use the quadratic formula, which I wrote over here. I started by listing a, b, and c, finding my discriminant, and I reduced the square root of 45 because 45 would have gone under this radical, which is 3 square root of 5. And then I just plugged it into the formula. Negative b would have been positive 5 plus or minus that discriminant over 2a, and a was 1. So that's how I got my final answer. All right, guys.